Still on circle geometry, the diagram shows a circle ABCD with center O and radius 7 centimeters. The reflex angle AOC is equal to 190 degrees and angle DAO is equal to 35 degrees. We have to find angle ABC. Next, angle ADC. Then the third one is that we have to calculate to three significant figures: the length of arc ABC and the length of chord AD. This is WASI 2008 question, theory part 2, number 11B and C. So we are asked, first of all, to get the value of angle ABC. So let's get started. Angle ABC that we are asked to find here is an angle subtended here at the circumference of this circle. So we first need to establish this fact that angle ABC is equal to half of angle, that is half of angle AOC here. That is half of reflex angle, half of reflex angle AOC. The reason is that angle subtended at the center is twice angle at the circumference. So we have angle subtended at the center of a circle is twice angle at the circumference. So that being said, angle ABC will be equal to half of 190 degrees, which is the angle AOC. And that's equal to half of 190 degrees is equal to 190 degrees divided by 2. And that's equal to 95 degrees. So for angle ABC, which is the first question we are asked to, or the first angle we are asked to calculate there, is equal to 95 degrees. The next is that we are asked to calculate the angle ADC. Where is ADC? ADC, this is the angle we have here. Also, before we can get angle ADC, remember this is another angle formed at the circumference. But the angle subtended at the center, which we are going to use to calculate this, is the angle that is subtended here. So again, we are going to have angle O here. That is, angle O will be equal to 360 degrees minus 190 degrees, and that's equal to 170 degrees. Now that angle O is known, this angle subtended at the center is twice angle at the circumference. So it means angle O is twice angle D, implying that for us to get angle D, we need to divide 170 by 2. So angle ADC is equal to 170 degrees over 2. and that gives us 85 degrees. Alternatively, another theorem that we can use here is that opposite interior angles of a cyclic quadrilateral is equal to 180 degrees. What that means is, once we know either ABC, we can get ADC. Either of the two angles that we know first, we can use that theorem to get the second one. That is, for angle B, or for the second question, ADC, we can use this and say angle ADC plus angle ABC is equal to 180 degrees. And the reason is opposite interior angles of a cyclic quadrilateral so this is what we have. So if ABC has been found to be 95 degrees, what that means is angle ADC now plus that 95 degrees will equal to 180 degrees. So that angle ADC is equal to 180 degrees minus 95 degrees. And finally, we have 85 degrees as the value of angle ADC, which is the same thing here. So either of the theorem that you want to use or that is easier for you, you can go ahead to use. Opposite interior angles of a cyclic quadrilateral, their sum equal 180 degrees. So if that is the case and we found ABC first, we can now arrive at ADC using this. The next question for us is to calculate the length of arc ABC. That is the length of this arc ABC. So we have this So this is arc ABC, and from the information in this diagram, we have AOC to be 170 degrees. That is, when you subtract 190 from 360, you get this angle that is subtended here. So what we have here is angle 170 degrees. And when you look at this shape again, the radius here is 7 centimeters. So coming back here, we will have 7 centimeters, 7 centimeters. With this now, we can calculate the length of arc ABC, because length of arc in this case ABC is equal to theta over 360 degrees multiplied by 2 pi r. Now, Subtended angle has been found to be 170 degrees. So we have 170 degrees over 360 degrees multiplied by 2 multiplied by pi, which is 3.142 multiplied by our radius, which is 7. So 170 times 2 times 3.142 times 7 is equal to 7,477.96. When you divide this by 360 degrees, we have 20.7721 in centimeters. That's approximately equal to 20.8 to 3 significant figures, as we were asked to express this. The last thing we are asked to do in this question is to calculate the length of chord AD. That is this line here, the length of this chord. So let's extract this diagram before we can proceed. Extracting the information around chord AD here, we are going to have this arc AD, then this is center O, that is this center here, then the radius from A to O, that is O, AO is equal to 7 centimeters. So here too we are going to have 7 centimeters. Again, if you draw a line from this point to D, that is also a radius of this circle. That is what you are seeing here, OD. And that implies that this too is 7 centimeters. Also, when you look at this diagram given to us, here is 35 degrees, implying that here is 35 degrees. And since this is an isosceles triangle with 2 sides equal, this base angle too is 35 degrees. Right? That is A is equal to D, angle A is equal to angle D, which is equal to 35 degrees, because you are dealing with base angles of an isosceles triangle. Base angles of an isosceles triangle. So, with what we now have, we can proceed to solve for the length of chord AD. But before then, look at this angle here. Let's label this alpha. What is the value of alpha here before we can proceed? Angle A plus angle D plus alpha is equal to 180. What's the reason? That's sum of angles in a triangle. Sum of angles in a triangle. So already angle A has been found, is 35 degrees. Angle D is 35 degrees. So 35 degrees plus 35 degrees plus alpha is equal to 180 degrees. 35 plus 35, we have 70 degrees plus alpha equal to 180 degrees. For us to get alpha here, we'll collect like terms such that alpha is equal to 180 degrees minus 70 degrees, and that's equal to 110 degrees. It means the subtended angle here is 110 degrees. For this, now we can proceed to solve for the length of chord AD, because the formula for calculating length of chord is equal to 2r sine theta over 2. You can see that there is a subtended angle here in this formula. That is why we needed to calculate this value of alpha, because the subtended angle here for this chord is different from the subtended angle here, which is 190 degrees, and the angle subtended here, which is 170 degrees. Since we are dealing with this chord, we need to focus attention on the angle here. That is why we've extracted this, and the angle subtended here is labeled alpha, giving us 110 degrees. So we are going to substitute or replace this theta here with alpha, since our own angle there, our subtended angle is alpha. So we can say length of chord AD will now be equal to 2r sine alpha over 2. Remember, this does not change anything. Theta here simply represents subtended angle, just like alpha. So that will be equal to 2 multiplied by 7, which is our radius. Then sine, our theta has been found to be 110 degrees. We'll divide that by 2. So, from what we have, when you multiply 2 by 7, you have 14. 14 sine 110 divided by 2, we have 55 degrees. So at this point, we will have 14 multiplied by sine 55 degrees, we have 0.8192. When you multiply 14 by 0.8192, you are going to have 11.4688. Then, since we are asked to take this to 3 significant figures, we are going to approximate it. That is approximately 11.5 centimeters to 3 SF. So this is the value of chord AD.